Welcome everyone to another performance clinic. Today's topic is distributed tracing with Dynatrace, and I have Sonja Chevre with me, senior technical product manager.
Hi.
You don't look that old to be senior, but I know you are from an experience perspective. Obviously, you have a lot of seniority. Thanks for being on the performance clinic.
Happy to be here.
Yeah, again, right? It's not the first time we do something like this.
Yeah, because as a senior, I had to do a couple of those ones to to get my seniority.
Yeah. So we also just published a podcast that we recorded a couple of weeks ago, but it got published last week. So for folks that want to learn more about distributed tracing, about open telemetry, about everything that happens in this space, also go to the Pure Performance podcast. Right? You can use your whatever app you use for listening to podcasts, or just find it on the Dynatrace website. But Sonja, I think this is a topic that is dear to your heart because you're driving this from a product management perspective.
Mm-hmm. Exactly.
Right? And I want to just actually give the stage to you, just reminding people, if you have any questions, use the question feature in GoToWebinar. And if questions come in, I'll try to throw them at you if it makes sense. Otherwise, I will keep it until the end. If these are questions that I don't cover right away, as always, folks, make sure that if you put the question into the question feature of GoToWebinar, be very specific so that also later on when we talk about them, that we know the context on where, on which particular topic. Also, I will be great. I will cut my video stream now because I think it's better to see you live that actually speaks. And I know later on you're moving to a demo mode, so then feel free to cut yours as well to give more space for the screen. But Sonja, take us away, enlighten us about distributed tracing with Dynatrace and everything surrounding it.
Perfect, thank you. Hi everybody, welcome to this webinar. We are going to talk about distributed tracing today. We'll start with an introduction, what it is, how it works, and then we'll deep dive into technical specificity with Dynatrace. So the first thing, what is distributed tracing? So you might have heard about observability. Observability has this notion of three pillars, the metrics, the traces, and the logs, being the data that you need to collect around your services, your application, to be able to understand what is going on with your application, with your services. And traces is one of these pillars, which is really important to help you do monitoring and to help you troubleshoot and also optimize your application. So we are going to concentrate today on traces. For metrics and logs, also part of our observability strategy, you might want to look at the great resource we have in the community. So distributed tracing is the technical mechanism we have to understand the control flow within distributed systems. So it's basically you have a request that goes through different services, and you really want to know, okay, what is happening with the request, to which services is going, and where is the error happening. And that's the distributed tracing is that mechanism that helps you to figure out where is the error happening and really understanding how the request flows within your system to the services. You might have noticed that distributed tracing is quite trendy at the moment, and you might have been asking yourself, is this a new thing? Actually, it's not really a new thing. This had been around for the last decade. I think we have a couple of patents that are more than 10 years ago around distributed tracing at Dynatrace. But one thing that have really changes now is microservice architecture on container platform have been making it much more difficult for developers to debug the application. In the past, a developer would work only on one specific process. They will have their editor and just do the debugging inside the editor and not needing to know anything else about the rest of the system. But as we move to a microservice architecture and that the services can be spin off automatically on containers, the developers started to need a way to understand what is happening with my request, to which services I'm landing to, and how the request really works. And this has been really a push. This developer push has really been a push into distributed tracing popularity. And another thing, some of the keywords around that you have been have been hearing around distributed tracing is, as it's become more popular, the use of distributed tracing for developers, operation for the whole DevOps lifecycle of your applications, there have been some initiatives to try to standardize distributed tracing. And we are, of course, part of them. So one of them is the W3C trace context. I'm going to talk a little bit more in details afterwards. Other projects include open tracing, open census, open telemetry. We are also going to approach those topics and what this means for us at Dynatrace. And this standardization efforts have also helped to popularize distributed tracing. Now, okay, that's for the concept, but how does it work with Dynatrace? What is distributed tracing and how does it work with Dynatrace? If you are already a Dynatrace user, you might know the service flow. The service flow is one of the primary visualization we have for distributed tracing. You see in the service flow all your services and how they talk and connect to each other. And how does it really work technically? So what will happen is you have your application, your services, and you deploy one agent on your host. And then our one agent, this really smart component, will automatically understand and detect all your services. So it will inject itself and do the basic code instrumentation into your application, your processes, to be able to define the services. So the great thing about that approach is that it's all automatic, meaning automatic injection, no manual configuration, automatic instrumentation. Best case, you don't have to do anything and one agent detects everything that's running on your system. And as one agent will instrument your application, it will start to send tracing data, of course also data like metrics and logs that we talked earlier, but this talk is specifically about distributed tracing, so I will only mention trace data. One agent will send trace data to our Dynatrace server, and now there's one really important piece of information that is missing is the trace ID, because on the backend, we need a way to be able to understand that the data sent from this service is the same request as the data sent from this, so it's just a continuation. We need a way to link the request together, and this is what is called the trace ID. So in Dynatrace, per default, we use our own vendor specific implementation. We add a HTTP header onto for example, if it's a HTTP call, we add our own HTTP header, which is Dynatrace, to your call to make sure that we are able to link one specific request along the way through all the services it goes to.
Hey Sonja, can I quickly inject here because the first question just comes in, and I think this is also a reminder for people that joined late that they can always ask questions using the question feature. So basically what you're saying here is that we create a trace ID at the beginning of the transaction, then we pass it on using an HTTP header from one tier to the next, so that every tier itself can basically send their own trace data that they capture from within the tier and the Dynatrace, and the backend can stick everything together. Now you mentioned HTTP as a protocol, and the question that just came in, how about other protocols than HTTP? How would that, for instance, work for messaging?
That's a great question, and we are going to talk about messaging during this webinar. So I have a specific use case for messaging. Basically, for HTTP, it's really standardized, and then the short answer is for messaging, it depends which system. So we have a way to inject this trace ID into the message or into the message protocol, different for each of the message protocol, but we are going to discuss that shortly, a little bit later.
Perfect. And also just to let people know, this is nothing that you have to do as a developer. This is all, at least from a Dynatrace perspective, handled fully automatically by the Dynatrace One agent.
Correct.
Thank you.
Thank you. So the result is you get lots and lots of traces in Dynatrace. Is that it? And the answer is of course not, because we don't want you to just end up with a list of traces and not being able to do advanced analytics with them. We don't want to let you hang in there and have to scroll and browse through millions and millions of traces to have to find the one that is really relevant for you. So what we do a little bit different than other solutions on the market, and not only little bit different, but really radically different. We have 4 core values that are really important to us. The first is automate it as much as possible. As Andy correctly mentioned, all these, including the trace ID generation, is done automatically. You don't even have to think about it. It's done for you. Then full stack, we are going to take a look at it at the next slide. We don't only have the distributed tracing layer, but we add the topology layer to be able to really understand what's going on in your system. AI is at the core because, as said, we don't want to have you to spend hours in data analysis. We have Davis, is like your assistant, he's doing it for you. And the last thing is we are at web scale. We know that the complexity is growing, the environments are growing, and we need to have an approach that is really easy for you to manage, to deploy. Everything should be easy and should be able to scale to your need. So how does it work? We were talking about observability, so these 3 pillars of observability: metrics, traces, and logs. While in other solutions, those are really like data silo that don't know anything about the other. In Dynatrace, we put metrics, traces, and log in context so that we are really able to get actionable data. And we are able to do this because we have a real-time topology discovery. So if you see how the AI works, so we build automatically a map of your environment. On one layer, so the horizontal layer is distributed tracing. We understand this specific application is talking with this specific microservice, calling this specific service. And then on the vertical layer, we understand automatically that this specific service is running in this specific process on this specific host in that specific cloud. So we really have a whole map to understand on many layers what's happening with your system. So if something goes wrong, for example, the go long process having issue, and this makes that the service is no longer reachable and the service that is calling it cannot call it anymore and the application is having trouble. Instead of generating 1, 2, 3, 4, or even more alerts, we group everything together. We understand that they are linked, and our AI, Davis, open a problem ticket for you. And will tell you, look, this is what's happening. We think you have about 500 users that have been impacted at the moment. This is the root cause. It's caused by this process that is impacting the whole system. And that's make it really easy for you to fix issues in production. You don't have to spend large amounts of time to really to understand what's happening. We do the analysis just for you.
Hey, Sonja, just because somebody just asked a question, if there's more details around the AI and all that, there is a performance clinic that I did with your colleague, with Wolfgang Beer, or with our colleague, on how does AI ops work with Dynatrace. So in case you want to actually know more about the whole AI and how we do as you just explained, the whole figuring out the root cause and all that stuff, there's already an existing YouTube tutorial on how AI works in Dynatrace, so check it out on the YouTube channel.
It's a really, really interesting one, yeah.
And there's another question that just came in, and I know I said I don't want to interrupt you, but I think because it just came in the scenario below, the question is, if I have an intermediate gateway, like an API gateway, it seems this customer is using Apigee. How does Dynatrace tracing then work through an API gateway where I don't maybe necessarily know the port of the vendor and stuff like that? So maybe you can just elaborate on
that. It would work in best case. It would be transparently. So let's assume this Apigee service is hosted maybe in the cloud, so you cannot install anything on it. If they are forwarding the HTTP header, it will be transparent for us. And that's something that we will also follow up a little bit later.
And I think the nice thing though is, I know you said transparent, that means if one service calls another service and it goes through an API gateway like Apigee or others, and they just follow the standards of forwarding HTTP headers, then it doesn't really matter, because then we still see the end-to-end trace. I think that's also the question. So how can we trace end-to-end if there's some middle component like an API gateway? It still works out of the box, assuming they are forwarding our HTTP header, or I think this is something where you'll talk about later with the trace context, but I don't want to steal your thunder.
Exactly. No, but that's good. So we see that the questions that people have are spot on. So you are really right in this webinar, and that these are topics we're going to address. Okay. Anything else, Andy?
No, not right now. Thank you. Go on.
Perfect. That's you know, I have one slide for you, and that's the slide I have for you. So
Oh
we
yeah,
were talking about production, you know, how distributed tracing helps together with the AI to help you diagnose issues in production, but actually distributed tracing is also helpful in pre-production. And since those slides I copied from your presentation, Andy, I think you are the best to give us a few words about.
Well, thank you. So I also turn on my camera for at least the one slide. So yeah, if you have followed any of the work that I've been doing over the last couple of years, it's the whole motion of shifting left and doing continuous performance, but also continuous architecture validation. You can see there's a blog out there where I talk about automated architecture validation with in CI/CD. Now, the nice thing about the trace data is we do not only know that one layer calls the other layer, we also know how many layers it calls. If it calls, as you can see on the bottom left, let's say a database more than once, like these N+1 query problems. We also have context information like the payload of a call. And so we can use this data fully automatically in a CI/CD setting. If you're executing builds or tests with every build, then we can look at the trace data and use the trace data to say, hey, from the previous build to this build, we just increased the number of database calls by 50%. We know this based on trace data. Or we added 2 additional backend services that we didn't have before. So was this intentional, yes or no? Or we are now sending 50% more bytes over the network. There's a lot of stuff that we can do with the distributed tracing data, not only for troubleshooting, not only for understanding the architecture, but really for automatically validating both, as I always call it, performance, but also architectural things, right? And check out the blog, and I think the trace data is really a magic thing here, because it can completely change the way we can do regression detection early on. And we have also you mentioned it here in the bullet points. The integration with testing tools is obviously very important, because I think you want to do this with after every test. And then we also have Captain as our open source framework, which has a quality gate implementation that's based on our library called Pitometer. Not Pitomer, but Pitometer actually. I didn't catch that in the review of the slides, but the Captain quality gates. And I also have a YouTube tutorial that is out there. If you are interested in more, search for my YouTube tutorial that is called Captain Quality Gates. Thanks for having me. Thanks for putting a slide in there that I can talk to.
Sure, I think it's really a nice use case as well, and it makes sense. So there's another question that we keep getting when people look for distributed tracing in Dynatrace. They don't see the menu to look for trace, because we have what is called the Dynatrace Pure Path. And so the question that we sometimes get, is Dynatrace Pure Path exactly the same as a distributed trace? And the answer is no, it's more than just distributed tracing. So you can see the Dynatrace Pure Path as being distributed tracing plus code level visibility. So basically, distributed tracing helps you to understand the boundaries between each services. And when there's an issue, distributed tracing helps you to understand from which service the issue is coming from, where does it stop, and where you should be looking. But it doesn't help you to dig deeper into the code and to understand where in the code is the problem coming from, where are you spending time in the code. This is what code level visibility provides. So if you look at a pure path in Dynatrace, you will see the distributed traces information, which services was called. We see we have first a web request going to different services, and then some requests being made to a NoSQL database, another service being called with a SQL database request, and then finally another request to a NoSQL database. And with the timing, how long did it take? So that distributed tracing, everything that is CPU time, I/O time, network time are things that we collect from inside the process by looking at what the CPU is doing. And we have an additional, so when you go deeper into maybe a more important pure path, you see code level, you will see here method hotspots. So we will tell you and dynamically capture information from your services to tell you where do we spend the most time in which method of your code. This is available for all the technology that we support out of the box. And that's really useful information, because you really want first to understand which service is impacted, and then you want to be able to understand where do you want to look in your code to help you fix that. And that's what code level visibility provides. So let me now show you everything in action. I'm going to stop my webcam to have more screen. So what you see now is called Smartscape topology. Smartscape is the model that we have built to be able to understand all the dependency, again, on the horizontal layer, distributed tracing, but also on the topological layer. And what you see here is the Death Star of one of our test environments. So here we see, we are on the services level, we see all the services communicating with each other. And all this data that you see here has been generated using trace data. So we see which services are connected to which services. When we click on a service, we see where is it on the topology. For example, you might have services that are running on different processes, even in different data center, multiple version, and we will have those two layers. First, how services connect to each other and how they fit into the topology, which is really helpful for us to understand the problem and key for our AI.
I thought, Sonja, also what I always do here when I explain the Smartscape, I always say on the left side is the vertical dependency map, and on the right side it's the horizontal dependency map based on the traces. So on the left is full stack visibility and vertical, and then on the right it's horizontal. So that's yeah, and I like the visualization. It's really great to explain kind of what data we have and the dependency information we can get from all of the traces and the full stack information.
And see how complex your system can be.
Yeah.
And then I can dive deeper into a specific service. I have chosen one of my customer front-end service from Easy Travel, one of our well-known demo application. And here I get already a short overview, what's happening, who is calling this service. I see 2 applications, and then this service itself is making call to 4 other services. What I like to do is also look at the requests that are being made. And I can, for example, select one request that is important to me. Let's look at the booking payment. So all this, again, is generated using trace data. And one thing that I like to do is to analyze the outliers to see, okay, how do my requests look like? And I can see, okay, there's a bucket of requests that are really quick, but there's lots of requests that takes longer time. So I want to look at it a little bit, and I can go to the service flow. And the great thing about the service flow, and that was one of the first screen I was showing you earlier in the presentation, is that you can filter it as you want. So we can filter it based on the request type, based on the response time, but you have lots of attributes that you can use to filter your analysis. And once you have filtered enough and you want to really look at the data, you can click here on View Pure Path and see what's going on. So we have here again on the left side the distributed tracing part. We see that I'm making a call from my customer front end that is making a call to my credit card, to my booking service to check my credit card. I have a credit card validator that calls a database. And again, if we look here on the code level tab, we'll see even more details from what is happening in the code, what is taking time. Anything else you'd like to add before I continue to the presentation?
No, I think, there's what I wanted to add in case people are interested in learning more on how to do diagnostics based on the traces that we have. There's also 2 YouTube tutorials that are already put out there. One is called Basic Diagnostics and the other one is called Advanced Diagnostics. I think that's what I want people to know.
That's good. That's good. Yeah, that's right, because here today we are discussing more the internals and there's lots to learn. So now we have been discussing the concept, and in the most case it works automatically out of the box, so you shouldn't even have to care about it, except if you're really technical and want to understand how it works. But what happens, there's several cases where the end-to-end visibility might be broken. And I want to show, to discuss a couple of use cases and what you could do. So one of them could be that you have in the middle, somewhere along your application, in your request, you have a middleware, a proxy, that is not forwarding the X Dynatrace header. So you remember we have been talking about this unique trace ID that is being propagated from one service to another to make sure that we're able to correlate all the, say, the trace data to the same transaction. And somebody asked the question about APG, so that would be, for example, an example for a proxy or API gateway or anything in the middle that we don't instrument. So the first quick thing to do, if that's possible, and that's possible for many applications, is to configure your middleware, your proxy, and enable it and tell the middleware to automatically forward the X Dynatrace header. So that's for proxy or some API middleware, something that's possible to configure. If you configure this component to automatically forward it, then you will end up with, you will get the end-to-end visibility from service A calling service B over this third-party component. Now, what if you cannot configure it? Or isn't it anywhere a little bit troublesome to have to configure something? So we don't want you, as Dynatrace user, we don't want you to have to configure anything. But at the same time, we cannot work with all the middleware components to tell them to automatically recognize the X Dynatrace header. And this is why we have been working with the community, with Google and Microsoft, on a standardization of this header. Instead of having all the vendors and all open source solutions come up with their own specific header for this trace context propagation, we have been working with the W3C on a standard. And this standard is called W3C trace context. And it defines, instead of using the X Dynatrace header, it defines a specific header, actually two headers, trace parent and trace state, that is used for the same meaning. So having a unique trace ID that is propagated from one service to another. At the moment, this standard is as candidate recommendation. And so we are one of the first earlier adopter of it. It means that as Google and Microsoft are working on this as well, we can expect in the future that they will have more and more services that will forward the trace context data in the header automatically, and that will help us all. So without you having to configure something in your middleware or in your API broker. How does this look? Is instead of having a X Dynatrace HTTP header, in the future, you'll have a trace parent and a trace state HTTP header. And as this is now standard, we expect more and more middleware, proxy, and other third-party components to understand that they have to automatically forward this data. So we have it already implemented in Dynatrace as a preview. You can register if you want to try that. Unfortunately, there are not many other implementations, so we are waiting for Google and Microsoft and others to follow this context. You know, this standard is still very new, so it's really great and promising for the future. And now it's up to the other vendors and cloud vendors to do their work and make sure this is implemented.
Hey, Sonja, also to add, because this is a conversation I always have with the customers I talk to, this is a great way for them to actually push their, let's say, cloud vendors, SaaS vendors, software vendors to actually implement these standards, right? So if somebody's using, if somebody is a big Amazon or Google customer, I'm not sure how much weight you have, but the more weight you put in, the more people actually say, you know, come on, follow these standards, the better it is for all of us, for the whole community, because then we get this implemented, and then end-to-end tracing doesn't stop with a middleware or with an API gateway that doesn't support it right now. Right? I mean, that's
exactly. And how does it look in Dynatrace? I say it's already supported in Dynatrace. We are among the first to support this new standard, and it was important for us because we are the one that also pushed for that standard. So when it is enabled, you will see in the request header, so in the pure path, in the detail of your pure path, you will see this unique trace ID and this parent pen ID, which is also part of the specification. And then in Dynatrace, you can also use this trace ID to filter your pure path for in the service flow. As said, this is currently a preview program. I have published a blog post about that to explain about the different use cases. And as Andy mentioned, so if this is something that makes sense for you, go to your vendors and send them the link to the specification. And we hope that in the next couple of months and year, we'll have more and more use cases, and that will help everybody in the community. Any question on that part before I move to the next?
There was maybe one that is kind of fits in here. It says Bill is asking, how does distributed tracing work again in the context of Apigee with Angular applications? I know this is kind of going back again to the stuff earlier where we said, you know, if something like Apigee is automatically forwarding the trace context, whether it's x-dynatrace or the trace context here, then you automatically get end-to-end visibility. And in the Dynatrace case, if we do real user monitoring, that means monitor your Angular application or whatever technology you use on the front end, and the Angular app or the front end app is making API calls to the back end through an API gateway like Apigee. The only thing you need to make sure of is that these gateways are forwarding this particular trace context, right? Whether it's the Dynatrace context or whether it's then the W3C context. Once that is done, then there should be no problem of doing end-to-end tracing, even starting from the RAM side, the real user monitoring side. And I think, Sonja, you actually have a section coming up later on RAM monitoring as well. But I wanted to highlight this here. A couple of other questions came in, but around whether the tracing also whether Dynatrace also supports OpenShift. So the answer is yes. We automatically instrument your OpenShift, your Cloud Foundries, and any of your Kubernetes flavors using a Dynatrace one-agent operator. It's very easy to find the material online on how you would roll out the one-agent on these PaaS environments. And the other question that came in from Thomas, he was asking how would we work with third-party applications where you don't have the source code available. So where you don't have the source code available, it doesn't matter if you have access, if you run this software on-premise or in an infrastructure that you own where you can install a one agent, then we obviously get also full visibility. This also is true for things like Lambdas, for things like Azure Functions, for things like Azure PaaS. We have one agents for that as well. The last thing Thomas was asking, how about things like SAP? If you have SAP in there, then again, it depends on whether it's SAP on-premise or whether it's SAP in the cloud. And I was telling Thomas that SAP is actually one of our largest customers that actually use Dynatrace in their SAP cloud to monitor the whole SAP cloud. So there's a lot of stuff here as well. And I kind of rushed through the questions. There's more coming in, and but I want to make sure that you get through your content, and I will keep the rest towards the end. But make sure people ask questions through the question feature.
Perfect. Thank you for the questions. As Andy mentioned, most of the things is done automatically. So you don't have to change code, you don't have to do a configuration. And before you start trying to think about how to solve issues, the first thing is to deploy the one agent and see what works out of the box, because you will be surprised how much one agent is able to capture and to detect and to understand without configuration, without anything needed from your side. Then, so I would say we aim to cover about 90% of your technology stack automatically. And then there are also always use cases that we cannot cover automatically, maybe 10%. And that's why we have come up with the one agent SDK. So if you are familiar with open tracing, the one agent SDK is kind of our own version of open tracing. And so if there is one specific technology, being a database engine or some remote calls or specific frameworks or even messaging that we don't detect automatically and that you don't see showing up in the service flow, we have for you the one agent SDK that can help you to extend the end-to-end tracing. But as said, once more, first you have to just look at everything that is done automatically and then figure out if you are missing one or two connections, for example, to a database. The great thing about the one agent SDK is no configuration needed. It works hand in hand with the one agent. So if you want to trace calls to a database or to a messaging system, you just have to add a couple of lines of code, and I'm going to show that. And then you can just add the missing end-to-end visibility. It's not only for end-to-end tracing, but such as database call, remote calls, HTTP requests or messaging, but you can also use request attributes. So we have in Dynatrace this concept of request attributes that enable you to put some metadata on the request, on the traces, that will enable you later to do advanced filtering and charting capability. And I think, Andy, you also already did a request attribute performance clinic.
Exactly. I did one that's called Mastering Request Attributes, where I'll show how you can define them, how you can use them for charting and for analysis. Exactly, that's all there.
Perfect. And soon with the One Agent SDK, we'll have also the possibility to push custom metrics with the SDK. But right now we'll look again at the end-to-end tracing. And the One Agent SDK is available for Java, .NET, Node.js, Python, and native. Once more, for Java, .NET, Node, and Node.js, we anyway have the automatically side that is working. It's only if you are missing one specific call and the end-to-end is breaking. So as always, first check what is everything that is done automatically, and then you'll see if you have the need, even the need for the One Agent SDK. So now let's go to the message tracing example. Somebody asked the question, and thank you for that. That's a question that we have been hearing. It's a good use case for the One Agent SDK. So first of all, once again, there are already many messaging systems that we support automatically, that we instrument automatically, where you don't have to do any changes. So first, again, try and see if the message call, the call to the message provider, is automatically instrumented, and if you have the visibility in Dynatrace. And if not, then you can help with the One Agent SDK. So in case your messaging system is not supported out of the box by Dynatrace, your service flow will look like that. You will have service A sending a message to the queue, and service B getting messages from the queue. And those two services won't be linked because Dynatrace wouldn't know that they are sending messages. The way to solve that is by using the One Agent SDK, and I'm going to show a short code snippet. And to put this specific ID, so this is again this trace ID we have been talking already, into the message or into the message protocol. So you have to make sure that you are able to push this as an additional metadata in your message. And in the service B, you'll use the One Agent SDK to retrieve this message and to put it and to tell Dynatrace. So you have to say, Dynatrace, I'm sending a message. You will get an ID, the trace ID. You'll put it in your message. And on service B, you will receive the message, extract the ID, and tell Dynatrace, I have received this message with this ID, and that will do the link. So I want to show you how that works. The example I'm showing is using the One Agent SDK. And to add the One Agent SDK for Java into your application, you just have to add one Maven dependency. Then we have a sample application, so it's part of the SDK. You can have a look. You can have a look at it yourself and try it out. When sending the message, you'll first have to create a messaging system info. So you'll tell Dynatrace, I'm using this specific message system, and you can pass some metadata. So what is the name of the system? What is the name of your queue? What is the channel? Some metadata for Dynatrace to understand how your messaging system works. And then you will start a tracer, trace outgoing message. And what is really important, and in this message, to add we call it Dynatrace string tag. This is the trace ID. So you will retrieve it from Dynatrace, and it's really important for you to put it into the message before you send it. On the receiving side, so this is a really, really basic sample. Everything is in the same file. But on the receiving file on your side, you will create an incoming message receive tracer, and you will say set Dynatrace string tag. So you will extract this ID from the message and put it back and tell Dynatrace, this is where you have to put it. So these two tracers, the trace outgoing message and the trace incoming message, will help Dynatrace to understand. We have a link to make here, and you'll have to, the really, really important point is you have to take care of the transportation of that trace ID yourself. So I'm just starting my example. And this is really an example that we deliver with the One Agent SDK, so you can try it out yourself, and this helps us to understand how to integrate into your application.
Pretty cool. Hey, Sonja, when you're looking for that transactional trace now, that pure path, there's a lot of questions that are coming in right now around support for specific, let's say, messaging systems or SaaS systems in the cloud. So David is, for instance, asking about Kafka tracing. I just sent him a link on the early access program. Then Ralph is asking for MuleSoft RTF monitoring in AWS clouds, and I'm not that familiar with that particular offering on the AWS cloud, but if it's a SaaS service, then you just want, I think from my perspective, you want to make sure that MuleSoft is able to pass on or pass through these headers, these trace headers, right, in order to get that through. There's also another one asking about MSMQ tracing. That's Shrida. He was asking that, and I sent him also a link to a discussion forum where we talk about the availability of MSMQ tracing, tracing through MSMQ. So there's a couple of questions that came in, and hopefully just make sure folks that are asking me questions in the question feature that you're also looking at my answers, because I try to answer some of those. Yeah, just wanted to highlight there's a couple of questions.
That's a good point. In January, we have a one page in the documentation that shows the list of technology that are supported. So that's the first thing you want to check through. And after that, you might want to look at the latest blog, maybe that hasn't been updated yet. And if there's a specific technology that's really important to you, maybe also think about posting about it in the community, because this helps us also to understand which technology are being used and what needs do you have. Because obviously the SDK helps you to solve your issues, but if more and more customers are using a specific technology, then we want to be able to support it out of the box. So the SDK is the first way to help you help yourself, but we are always interested to learn what is popular and what should work out of the box.
And also maybe, I'm not sure if you know it, but Justin is asking about akka.net. I know we have support for akka client and server libraries, but I think it's Java. I'm not so sure about akka.net. I also pointed him to that page with the supported technologies. But yeah, there's a couple of questions that come up on specific supports. Yeah.
Cool. So this is the service that is sending the messages, and now you see here that I have one queue that is being displayed. This is the name of my queue. And if I look at the service flow, what I will get is this is the service that is sending the message. Then we have the message on the queue being visualized, and then we generate two services. One is the queue listener. It means when did I receive the message, and the service we call the receive message is the one that is processing the message. And these snippets of code I showed you helps to make the connection. So if you have anywhere in your code one pure path being started, stopped, and another pure path being continued, and you want to glue them together because you know there is some messaging happening in there, you can really use this functionality. And this will help you to get the end-to-end, which is really desired. So the more end-to-end you have, the better Davis or AI will be able to work with the data. That's it. We can also have a short look at the pure path. Exactly, we see also when the message was sent, and the queue, and when it was being processed. So. Again, there's a couple of blog posts and documentation for you out there. So the key thing is to remember, first have a look at everything that works out of the box. Have a look if you have any preview program coming up with the technology you are interested into. Maybe post a blog question on answers. And if we don't cover it at the moment, you can help yourself with using the One Agent SDK for database call, for messaging, for remote call, for everything that we need to glue transaction together.
Hey Sonja, one question that just came in. Do you have any demos out there that actually show the trace context header instead of the x-dynatrace header?
Out there we don't have it. It's in a preview, so you can register on. If you look for the blog post, you can register for it, and we can enable it for you.
Okay, perfect. I will. Whoever asked the question, I will send you that link to the preview. Perfect. Thank you.
No. Now we were talking, the use case I used were for Java. So in the case of Java, we do everything automatically, and the One Agent SDK is only good for the last pieces that might be not detected automatically. But what about additional technology that we don't support out of the box, like native, Python, Ruby, whatever? For that, we have released the One Agent SDK for C, C++, and as many other programming languages are able to work with C code, you can easily write a language binding that will work, that will enable you to create your own SDK in additional languages. So what we do is right now we provide the One Agent SDK for C, C++, and we provide the one for Python that just is the interface to the native SDK. And for example, for Python, you can again use the SDK to trace fully your Python application. I have another blog post and demo code out there that show you how to instrument a Flask application. So Flask is one of the frameworks that programmers like to use for Python. That's really popular. Together with Django, Flask is one of the top two. And there's a tutorial out there and a source code, so have a look. Now, we have been talking a lot about the server sides, right? But what about the end user side, web, mobile? So we have a part of our offering which is called Dynatrace Real User Monitoring, and this is for the end user side. And it's really important to start the trace on the client side, because if you get only visibility or details on your server side, you actually don't know when something is happening, if your user are impacted, if they're happy. Maybe you might have a super service that is running with perfect KPI, but on the front-end side, users are angry or frustrated and you don't even know about it because you lack the user visibility. So putting it all together, having the trace starting on the client side in the broader mobile app or any custom application being linked automatically with the server side is one of the key things that will help you understand your user and also understand what is happening in case of an outage. This is done. I'm not going here into details on how this is working. I think we have also lots of great materials I have linked there. This is also something that we do automatically. So if you have a website, we can instrument the HTML code automatically, and we provide you with lots of insights on what your users are doing and what you can do to help them get more happier.
Even more happier than people already are.
Now, one of the last topic for today, before we jump back to the question, is what about open tracing, open census, and open telemetry? So open tracing and open census were up to earlier this year two competing initiatives trying to provide vendor-neutral APIs and SDKs for distributed tracing. And we have been thinking for a long time which one of the two options should we offer to our users. And we were really happy when they started to work on the merge. So open tracing, open census is coming from Google, and we have been working with Google in the background for some time. And now the new project is called Open Telemetry, and it's great because it's simply the merge and the next major version of both projects. Open Telemetry is not available yet, so the community is currently working on merging these two projects and making sure it makes sense and everything works properly. And actually, we Dynatrace are also part of OpenTelemetry. So we have a dedicated team of engineers working with the community on providing the first version of OpenTelemetry. On the other side, we're also working on how the OpenTelemetry support will look like in Dynatrace. So I have a very, very, very early screenshot for you. This is the first time I show it, and it's not done, even as, of course, OpenTelemetry itself is not done. But what we want to do is specifically for use case where we don't support out of the box. I'm thinking about, native code like Envoy, a really, really interesting proxy used together with Istio Service Mesh. It's a native code. We cannot instrument it automatically. So having OpenTelemetry traces for that kind of services would be really a benefit for us. So this will open many use cases for us. And right now our work is working with the community, making sure that OpenTelemetry has all the requirements that are close to our eyes, to our heart, making sure we are able to provide you, users, with a solution that will be, again, full stack with AI at the core, and that will be able to scale. So lots of interesting development will come within the next months in that area. Again, I would say everything that works automatically, you don't have to even think about it. And we are going to use OpenTelemetry to expand into technology or platform we cannot support automatically at the moment. That's it.
Awesome. Hey, there's a lot of additional questions that came in, and I want to actually go back to the video first of all, right? Because we are not shy and we want to make sure that people see us. So thanks, Sonja, also for all the links here. As you folks that have never been on these performance clinics, the video or the tutorial has been recorded, and we will also put it up on the YouTube channel as well as on Dynatrace University. Sonja, I know there's a lot of links. I think that's just the summary of all the links that you had in your slides anyway. By the way, we also upload the slides to Dynatrace University, so for Dynatrace customers and partners and trial users, you can also get the slide deck later on. Sonja, would you do me a favor before we go into Q&A? Go to the next slide. I think I have a couple of additional links that I want people to know. Exactly. So if you have not experienced Dynatrace yourself yet, get your trial. Go to the website and just sign up for the trial. You can also just use this link here, but with both a SaaS trial and also you can also request a managed trial or managed POC. Managed means you can actually install Dynatrace, the backend system on premise. There's a lot of videos out there that I have. A lot of questions came in on, so which technologies are supported, how to get started. I have a video. The first video on my playlist is actually about what is Dynatrace and how to get started, and I basically just roll out a one agent on my local machine, and you can see how easy that is. There were also questions that came in on support for OpenShift and Kubernetes. Yes, full support for it. That means we have a one agent operator where the only thing you need to do is you need to install that operator on your Kubernetes cluster or OpenShift cluster, and then the one agent will automatically be rolled out, automatically instruments the cluster, every container, every service that runs fully automatically. And also a lot of questions came in about which technologies do you guys support? Where do I need to use the one agent SDK versus what can Dynatrace do automatically? I think, Sonja, you mentioned it, but to repeat, for Java.NET, PHP, Node, Go. We instrument this fully automatically, no code change necessary, whether it's your own code or whether it's code that you are kind of inherited or run on, because of a third-party provided that. We also have support for different SaaS PaaS solutions. Let's say I mentioned earlier AWS, Lambdas, or
Azure, .NET Azure Functions.
Exactly. All this, right, it's all supported. And for, let's say, the rare cases where you have really a native component that you cannot instrument with Dynatrace One Agent automatically, you have the One Agent SDK.
Or using a proprietary protocol that we are not able to understand.
Yeah, exactly. So there's more links here. Please check it out. There's one last slide before I then really go into the questions. We also have a lot of events coming up and actually ongoing right now. The big one that all of these events, the World Tour of Perform is leading up to, is Perform in Las Vegas, first week of February. So I assume, Sonja, I'm not sure if you will be there. Yes. Awesome. So I'm pretty sure open tracing and distributed tracing is going to be a hot topic there as well. Talking about hot, we also have hot days, hands-on training days, Monday and Tuesday, that you should check out. And in case you are in anywhere near these cities that are listed here, you can see that Shanghai is actually happening tomorrow, then there's Chicago, Madrid, Paris, and so on and so forth. So there's more of these local perform events coming up. Now to the questions. So most of the questions that I still have open and I tried to answer are all around technology support. And again, there is a page, if you can Google it probably very easily, and it's the technology supported technologies and versions, right? That's basically what it is. Yeah.
That's
exactly.
the one.
That's the one. Yeah. There's also a lot of questions about what's the difference between when I have a system running in the cloud versus on-premise. So with the one agent, if you can install the one agent on the system that runs your software, then it's obviously very easy. You can then just install the one agent. If you have a true SaaS solution that you're leveraging, then you need to talk with the vendor on how to deploy the SaaS solution. But in most cases, I would assume they don't allow you to install a monitoring solution. But this is exactly the point where you guys out there need to push your vendor on supporting and implementing these standards, open telemetry and trace context, right? I think that's important. What else do I have here? Is Dynatrace smart enough to not overload the system? So actually, I mean, with one agent is intelligent to limit the number of pure paths emitted from this one agent when it emits too much. When this mechanism turns on, what's the solution Dynatrace provides to make sure we can have at least a small set of non-broken pure paths across the whole system? So and how can we make sure that we can easily find these pure paths? So I think there is exactly. There's a great blog post again, right, that talks about how we deal with actually capturing pure paths and how we ensure high fidelity. So adaptive traffic management and control. That's a great post on the doc page. Now, also to the question, how can I find the pure paths? I know our previous generation product, AppMon, we kind of educated, and I am guilty as charged because I did a lot of videos out there on how to navigate the pure path, and I got everybody excited about navigating the pure path. But the first thing you want to do, especially in a high load environment, you don't necessarily want to go to the individual pure path, right, Sonja?
That's right. So just too much information, just to an overload, and you will get lost.
Exactly. So we obviously have the pure paths, but I think you showed it earlier. You did the outlier analysis. You can use the Dynatrace response time hotspot analysis to actually crunch through the data for you and then give you the ones that are actually problematic. You can use the Dynatrace Davis AI to actually tell you in case there is a problem, and then Dynatrace also gives you the root cause because we have the whole dependency map, right? So
and also the great thing is we don't show you the whole trace. We always show it from the start where it's important to you. Because, you know, into this environment, you would get traces that have components you don't even know and have to know about. So when we start the service trace, always from their service, that start to be interesting for you. Of course, you can do a backtrace analysis to see what happens before, but we always try to show you what is meaningful for you.
Yeah, and that's actually really cool. So we always have the end-to-end trace, but most of our views in Dynatrace are specific to, hey, I'm the owner of that service, so show me what's actually happening within my service, and then give me the information who is calling me. Maybe they're calling me wrong, or who am I calling, and what am I doing wrong? There is another question.
And maybe you can always, so as you said, Davis, to just Davis tell you. Look at this pure path, the issues coming from there, the service flow, and then you can have a look. If you're doing analysis, every charting, every component helps you to filter it down till you get to the pure path that are relevant to you.
Mm-hmm. And again, make sure that you're checking out the basic and the advanced diagnostic performance clinic that I did. The other next question that just comes in will be interesting if the PaaS agents, so the one agent that we have for PaaS, can support memory dump triggers. I guess this depends on the PaaS environment, right? If you think about, I don't know, a Lambda function in some language, the question is, does the underlying provider, whether it's Azure or like a serverless function, whether it's Azure or AWS, allow us, so Azure App Services, can we do memory dumps on Azure App Services? These are the questions that are just coming in. I'm not sure about, I believe I actually don't know if we have the control to actually tell the .NET runtime that Microsoft is hosting to actually trigger a memory dump. I don't know if you know, Sonja.
No, I'm not that deep into that project.
Yeah. So Sridhar, if you can do me a favor, use, you said you tried and it didn't work. Do me a favor, post this question to answers.dynatrace.com, because then we can get the right people answer these questions and maybe say, well, maybe they can answer them. Well, it's technically not possible because Microsoft doesn't allow us to do it, or we have it on the roadmap, right? I think that's always great questions for the forums, answers.dynatrace.com. All right. I think the other questions, folks, make sure you check the answers that are posted in the Q&A window. And I think I answered all of the questions at least. Sonja, thank you so much for this.
Thank you so much for having me.
Yeah, I'll definitely want to have you back. As open telemetry is maturing, both from like globally as the community, and also then as we have more and more features in Dynatrace. So yeah, thank you so much, and I'll see you in Linz next week. Okay.
Perfect.
Yeah. All right. And thanks for everyone that was listening in.
Thank
all the
you,
best.
everyone.
Bye bye.
Bye bye.